This is Brian Putt. I'd like to talk to you about flipping a conditional probability matrix in Excel without any simulation, and then maybe show how you can use that conditional probability matrix in a simulation. In an earlier email, I outlined the methodology using the taxi cab problem. You may wish to go back and review that if you're unfamiliar with Bayesian flipping of trees. And now I want to talk about an asymmetric tree, as shown here. It has three reality nodes, A, B, and C. And for each of those reality nodes, there's four possible outcomes. It indicates A, B, C, or possibly it says, I don't know. I don't know which one it is. And obviously, given the reality, the total has to be 100%. And we now want to flip that tree. So what we're going to do is calculate the joint probabilities. So over here, I've calculated the joint probability. I've taken the probability of A times the probability of reality A times the indicator A, and multiplied that across. And you can see if we add those up, it comes to 60%. Reality B, same thing, and reality C. Now, to get to the probabilities, the conditional probabilities of, given an indicator, what is the probability of reality? All we need to do is to take the probability of the joint probability of A, indicator A, and divide by the probability of indicator A. So in this case, I'm going to take 42 and divide by 47. And when I do that, I get 88.9%. And that's consistent with saying, hey, reality A has the highest probability. It also has the highest probability for indicator A. So we do that for all of these. Let me just take another one. We're going to take the probability of the joint probability of reality B and indicator C, which is 2.25, divide by the probability of indicator C, which is 20.25, and that gives me an answer of 11.1. So by definition, if I'm looking at the flipped tree, if you will, so I'm going to be given the indicator, it has to be, the sum of these indicators has to be 100%. These are the probabilities of each of the indicators down here, which is simply the sum of these. And we know that given an indicator, let's say I'll use the indicator question mark, that if I get an indicator question mark, the sum of the outcomes, it has to be one of those realities. So now that I flipped this tree, let's ask the question, how do I use these? I guess I already have a SIPmath generated table here. But let's say I wanted to, I have a reality and I have a indicator. And now I'm just going to generate these two random variables for you, and then how they get used to the model to determine whether the indicator gets known before the reality. What I need to do is to resample, excuse me, not resample, but do a discrete distribution where the values are here, probabilities are here. I need a place for cumulative, so we'll just put those there. And I need a seed. Oh, we'll just stick with that. We'll just put in a 1001. That's all right. Okay. So now let's pick reality A, and I can do a match here. Equals match. Did I spell that right? No. Match this to here, comma, 0. So it tells me on the first one. All right? So now I need to get my indicator. So to do this, to get the indicator, I need to get the cumulative probabilities of these numbers here. So So what I'm going to do is I'm going to come over here and put in some zeros. And here it's going to be equal that plus this number here. Okay. So this is going to be the cumulative probability. And now the indicator, I need a random number here. So we'll put a random number, generate a uniform right there, and we'll say OK. And now this is equal to match this number here. Now what do I want to do? I want to match that number in one of these cumulative lines. In this case, we have reality A, so I want to look at this column right here. So to do that, I'm going to use index and highlight this whole array, comma, I want to use the first row, and I want to use the whole vector. So if you specify as 0, it uses the whole vector of the index command. And then I can finish my match command. And it tells me I have a 3. And so then given that 3, I can equals index. I'm just going to put the name here now of that cell there. Oop, too few arguments. Index. Oh, I need to highlight this, comma, there. So it's indicator C. Now, if I come up here to SIPmath, I can test this. Go to trial information. Okay. So this is trial 1, where based on the random number, which I don't have here, you know, it would probably be better for transparency to actually generate a random number here. So let's do this. Let's regenerate this distribution. I'm going to put a SIPmath generated input uniform, and I'm going to put a there. Oops. That was 1003. I'm going to generate a random number there. Okay? I'm going to close that for the time being. And then let's regenerate this. So I'm going to come up here to SIPmath, generate discrete. And the values are here. The probabilities are here. The cumulatives are over here. And now I'm going to use this external random number, which is what I calculated right here. Okay? Now I use a user. And it tells me that A6 is not empty, and I'll say yes to all, because all of those, it was expecting empty cells. Yes to all. All right, so now let's look at what we have. We got a 0.6. So it's a little bit over 0.6, so that means I got a reality B. And for this one, I got an 87. So if I come over here to these cumulatives, 87 is above 75, so I got indicator question mark. Now I'll come over here and get do trial information. We'll test it with a few others. There's trial 2. Trial 2 is a 0.1, which is less than 0.6. And therefore I got reality A. This is a 76, and 76 is bigger than A, bigger than this 70, and therefore I got indicator B. So this is working right, and you can see I get different combinations here. And now these results of indicator and reality can be used in your model to effectively do a Bayesian decision tree, and you could base your decisions on the indicator. Thank you for watching.